Hey guys, Ashman here, back again with another video, and in today's video I'm going to show you how to make a basic linear regression model with TensorFlow and Keras API. So for this video I'm going to be using the Google Colab, but if you are using Jupyter it is absolutely fine because they both have a very similar user interface, so you're not going to have a hard time understanding what I'm doing. So linear regression is basically an algorithm used in machine learning to predict values, and we are going to be seeing how this linear regression model is made, and I'm going to show you a very basic one made with TensorFlow and Keras API. So let's get started with it. And for this video I'm going to be using Google Colab, but as I said before, if you are using Jupyter it's absolutely fine. But if you are using Colab, then it will be very easy for you to understand what I'm doing and you can get along quicker. So let's get started with the coding part. And I've actually already connected my Colab with one of Google's server. But before getting started with the coding part, I'm going to suggest you to go to the runtime part and change the hardware accelerator to a GPU, because if you use a GPU, then your computations are going to be much more faster, because machine learning is a very math heavy branch of computer science. So all the computations and the matrix multiplication, everything which happens in machine learning is done way more faster on a GPU compared to a CPU. It's even more faster on a TPU, but TPU currently with Colab, if you use a TPU, you lose some of the features of Colab. So I would suggest you not to use a TPU at first. So it's better to use a GPU, because actually there is not a lot of difference. So with GPU, you will still not lose so many of the Colab features. So but for this video, because I do not have a GPU access, because there are limited GPUs in the Google's server somewhere, so that's why I'm not able to use GPU today, but I'll be using a TPU, but that's absolutely fine. So first of all, before getting started, we are going to import two modules. So we are going to first import the TensorFlow module. So we will type out import TensorFlow as df. As you can see, the docstring is coming up very nicely. And we are also going to import NumPy. So we are going to type out import NumPy as np. So that's really cool, and we have successfully imported two of our modules required for this video. And we are also going to create two arrays, and between that two arrays we are going to set up a linear relationship. I'm going to show you how I'm going to do that. So we are going to create two variables, one an x and a y. So both of them going to have two arrays. So first of all, let's create the x one. So x variable will contain an array, and we are going to create the array using the np arrange method, which is in the numpy module. So np dot arrange, and let's say it has 50 numbers in it. So let's do that, and let's see the array. So as you can see, it is a one-dimensional array, and it has values ranging from 0 to 49. So it has 50 values in the array. So that's pretty cool. And if you want to see how many dimensions it has, so visually, as you can see, it is a one-dimensional array. But if you want to see numerically, you can just type ndim, and you will get the dimension of the array. So as you can see over here, it shows 1. So let us create another array in the y variable. So let's create that. So y is equals to, but this time we are not going to use the np.arrange, but what we are going to do is we are going to type x plus 10. So what we have done right now is we have set up a linear relationship between x and y. So let's show you both x and y visually. So x comma y, and as you can see, both of them have the same number of elements in the array, but the difference is each of the element in y is plus 10 of the elements in x. So in the first column and row we have in the first index we have 0 in x array, and in the y array we have the first element as 10. So this is 10 plus more than 0. So as you can see, so each of the elements are plus 10 of what is there in x. So this way we have set up a linear relationship between x and y. So that's pretty cool. So now we are going to create our model, which is going to learn this linear relationship between two of the arrays, and with that model we are going to predict a number with the help of the model. So let's do that. So I'm going to create a new code cell, and I'm going to first of all set the seed. So I'm going to type out tf.random, that's a typo, tf.random.set seed, and we are going to set it as 42. So set seed is basically a function to save the random state of the function, and it's basically for reproducibility of random numbers. We are not going to get into that a lot too much, so I just told you on a high level what it is. So basically it is for reproducibility of numbers. So just for your reference. And now we are going to create our model. So we are going to create a variable model is equals to tf dot, because we are going to use the Keras API. So we are going to type tf dot Keras dot models dot sequential. But you can also type it like this if you want to make your code a little bit concise. So you can also do tf dot sequential. So it's pretty much both of them are the same thing. So whichever way you can do it, it's absolutely fine. So it's going to be a list of layers. So that's why we have the square brackets over here. So let's go back, and now we are going to create one dense layer, which is going to learn the pattern between the x and y arrays. So we are going to create a dense layer by typing out tf.keras.layers.dense, and let's say it has one neuron initially. So we have just created a model which has one layer, and the layer has one single neuron. So we are going to see how it performs, and accordingly we will improve our model, and we will see how it goes. So now what we are going to do is, another essential part of making a model is to compile the model. So we are going to type model.compile, and we are going to set the loss function as tf.keras.losses dot it's going to be mean absolute error. So we are going to use the mean absolute error as the loss function for this model, and we are going to set the optimizer as tf.keras dot not layers, tf.keras dot optimizers dot sgd, and sgd stands for stochastic gradient descent. That's an optimizer among tons of other optimizers like Adam and many other optimizers. So you can use sgd, and sgd is actually preferred for linear regression, but Adam, which we are going to see later on, is actually better for linear regression than sgd. So then we are going to set the matrix as we are going to set the matrix. Oh, I forgot to put equals over here. We're going to set the matrix as MAE. So we have just created the compile function, and now we are going to fit the model with our x and y arrays. So model dot fit, we're going to pass in the x array and the y array, and we are also going to set the epochs to, let's say, 10 initially. So basically the epochs means number of times the data is going to pass through each of the layers in our model, and it is going to run this model 10 times basically. So that's what the epochs means. So now we are going to run this code cell and we see how our model performs. So let's run it. So as you can see, it happens very quickly. So the MAE is decreasing, as you can see. With each epoch it is decreasing, but it hasn't reduced a lot from here. As you can see, from the fifth epoch the difference isn't that major. Actually, suddenly in the 8th epoch, the MA increased. So that's pretty strange. But so we can see that our model is not performing pretty well. But let's see the prediction of the model. So we are going to predict a value. So let's see how does it perform. So model dot predict, and we are going to pass in a value. Let's say 20. So the expected output of this prediction should be 30, because as you can see before, between we have done over here, each of the values of over here are plus 10 of each other. So basically, if we pass 20 over here, we should be getting 30 as the output, because we have set up a linear relationship, which is each of the elements passed are plus 10 of each other. So that should be the output. Basically, we should be getting 30 as the output. So let's see what is the output which we get. So let's see that. So we get 26.17. So we can ignore the decimal part of it, but basically we're getting 26 as the output. So uh, it's okay, I would say. I mean, it's not very close. So it's 60% accurate, but it's not that good. So we can improve our model so that we can take it closer to 30. But still, initially with just one layer and one neuron, it's not a very bad prediction. So what we can do is, to improve our model, we can add one another layer to it. So let's add another layer to our model. So tf.keras dot layers dot dense, and we are also going to have one single neuron for this one. So let's see if that makes any difference. So let's run it again. Okay, that was not good. Our MA increased compared to the previous model. So that's a very bad sign. So that means our prediction is going to be even more terrible. So let's see. As you can see, it's basically just printing out the same number, 20. So yeah, the MA is, this model is not working well. So what we can do is, we can increase the number of neurons in each layer. So let's make the first layer have 10 neurons, and the second layer have only 1 neuron, and let's see how does it perform. Not very different. So let's see what we can do. So another thing which we can do is to increase our number of epochs. So the more number of time, the more we increase the epochs, the better it can learn. But we have to make sure that the model doesn't overfit. So we are not going to get into the concept of overfitting now, because this is the basics. But let's see, by increasing the number of epochs, if it makes any difference in the output. Okay. So yes, it has made a slight difference. The MA is decreasing, but not by a huge margin as expected. So the another change which we can make to our model is to change the optimizer function to Adam, and let's see what difference does it make. This is basically how you just experiment and see the output of it, and this is the way you actually get better at machine learning and making models. So this is, you have to experiment and see which one works out the best. So as you can see, the MA is decreased a lot by just changing the optimizer function. So it is now at 3.84, which is a good sign. So now we are going to see our prediction. How does our model predict? Okay, it's 26. So again, we are kind of getting this kind of same result as we did for the first time. So not a lot of difference, but still better than the previous model which we had. So let us see what are the differences or changes which we can make to our model. So let's do a thing. Let's create 3 dense layers in our model. So we are going to create another dense layer. So tf.keras.layers.dense, and this is going to be having 1 neuron. But in the first layer which we have over here, we're going to have 100 neurons, and in the second layer we're going to have 10, and in the third we have going to have 1. So this is basically like a triangle, as you can see. So 100, 10, 1 over here. So let us see how our model performs with this kind of a setup. So let's run it. I hope it should be doing it better than before. Okay, so yes, the MA reduced by quite a lot of numbers, and let us see how does it predict. Okay, we are closer to 30. We are closer to 30. Okay, let me just type out over here by commenting that our target is to get the output value as 30, so that you can understand what we are trying to get here. So as you can see, we are getting 27 right now, so it's pretty close, but still not close enough. So let's see what are the difference can we make. So pretty much what we have covered so far is like increasing the number of layers, increasing the number of neurons, changing the optimizer function. So we have done quite a lot of stuff, but another thing which we can do is to increase our epochs. So let us increase it to 200. So I think by increasing it to 200, our model is going to learn better than it did before with 100 epochs. So let's see by running the code cell again. So I hope it does better. Oh yes. Oh yeah. The MAE has pretty much reduced to 0.3. Previously I guess it was around 2.7. Now it's 0.3. So that's a huge difference by just doubling the epochs. I'm sure now the model is going to do a much better job than it did before. So let's do it and let's run it basically. Let's see the prediction. Yes, so we are getting 28.9655, so we are getting close to 29. So this is the best output which we have got so far. It's very close to 30. So as you can see, by making a lot of modifications to our model, we have like at the end we have been very close to our goal, which is to get the value output as 30. So let us go step by step what we have done so far. First of all, we made a very basic model with just one layer with one neuron. Then we increased the number of layers to 2 with again the second layer having only one neuron. Then we changed our optimizer function. Then we added another layer to our model. Then we changed the number of neurons in the first layer to 100, the second to 10, and the third layer to 1. So this way we increased the number of layers and the number of neurons in our model. So in that way our model is able to learn much better and is able to understand the linear relationship between both the x and y arrays much better. And by changing the optimizer function to Adam, the model is able to understand and rectify the errors in the model way more better compared to stochastic gradient descent or SGD optimizer function. So, and we also changed the epochs to 200. So by doubling it, we have been getting even way better results than we did by just keeping it on 100. So this way, as you can see, by just doing permutation combinations of different functions and different number of neurons and layers, you can finally get your desired output, which in our case is 30, because we passed the value as 20. Even if you pass any other value to the model, let's say we pass 56 for some reason, so we should be getting 66. Okay, we didn't get 66, but we got 63.25, so which is pretty close to 66. Let's pass in another value. Let's say 35. So let's see how does it perform. So we are getting 43, so not too far off, pretty close, but still pretty good compared to all the previous models which we have used before. So this was basically my video regarding the basic linear regression model with TensorFlow and Keras API. Hopefully I hope that you understood whatever I told in this video, and I think you found it helpful. So thank you for watching, and we'll make more videos in the future.